Okay, so like I mentioned, we found the acceleration at point B. We can now use point B to go and find the acceleration at point C. We'll write then that the acceleration, well, we have two options. We can write the acceleration of C in terms of B, or we can write the acceleration of B in terms of C, and so we're going to do that. We're going to write that the acceleration at B is equal to acceleration AC plus alpha 2 crossed with R B slash C plus omega 2 k hat crossed with omega 2 k hat crossed with R B slash C. And earlier we found that omega 2 was 0. So this entire third term is going to go to 0. This is going to give us then that AB is equal to AC plus alpha 2 crossed with R B slash C. We also know that, I'm going to scroll up here, because point C is restricted to move vertically, we can express its acceleration in the vertical direction only. So we can say then, we can let AC be equal to some scalar AC in the j direction. And then we'll write that AB is equal to ACJ plus alpha 2 scalar in the k direction crossed with, and now we'll plug in for RB slash C, and we'll have minus BI plus HJ. At this point, we don't know the direction of alpha 2, whether it's negative or positive, so we're going to make an assumption. We're going to assume that is positive. And if it's not positive, then when you go and solve for this, you'll find that it's actually negative. So it will work out just fine. So we're going to assume that it's positive, and then we'll go and compute this. We'll get AB is equal to ACJ plus, or actually minus B alpha 2J minus H alpha 2I. From here, we're going to set this equal to the other expression for AB that we have above there. So this is equal to minus A omega 1 squared I plus A alpha 1J Then from here, we're going to equate the components. So in the I direction, we're going to get minus A omega 1 squared equal to minus H alpha 2. There we can go and solve for alpha 2. Where our alpha 2 vector is going to be equal to A over H times omega 1 squared. This is in the k direction. And it turned out to be positive, so our assumption was correct. If we had gotten a negative here, then it would mean that our assumption was incorrect. We would have had it in the other direction. For j hat, we're going to get AC minus B alpha 2 equal to A alpha 1 And then we can solve there for AC. And that's going to be equal to the A times alpha 1 plus B alpha 2. And we now know what alpha 2 is, so we can go and we can plug this in, and we'll find then that AC, the acceleration vector, is equal to A alpha 1 plus AB over H omega 1 squared J. And that is the solution to alpha 6.